Hello friends. First of all, I am brother Joshua CMI. Now I am just substituting Father Lijo for 1 or 2 classes. Okay. So welcome to physics. As you know, we are now today dealing with the first chapter that is called matter. Now first I want you all to just comment that you all came here. So please comment that you are ready in the comment box. Okay, so let's start. You have already studied what is matter, but I will once more start from the basics. So about matter, what is matter? Matter is something that occupies a particular space. Occupies a space. This is the first point. Another thing, matter is a substance that occupies a space. At the same time, it must have a mass. This is the basic of what is matter. We will explain it like this. It should occupy a space and it should have a mass. In your textbook, they have written one more point, that is, it can be perceived by your senses. So simply, matter is that occupies a space which has a mass and which can be perceived by our senses. So this is the simple definition of matter. Whatever we see in the world, be it living or non-living, all things are made up of matter. Be it a rock, be it a bench, be it a human being, be it an animal, everything is made up of matter. Okay? So I want all of you to study this. In between, I just want all of you, if you have any doubt, you just comment in the chat box. I will get it and I can rectify it. Okay? And also, I need all of you to take down the notes if you have no textbook. Or if you have textbook, please follow the textbook if you want. Okay? So this is all about matter. Now we will see how matter is composed of. Okay? The most tiny particle that we come across is molecules. We say like this: molecules are tiny particles and matter is made up of tiny particles called molecules. These molecules make up a bigger matter. Okay? And these molecules are again made out of atoms. Okay? And these atoms is divided into two. Monoatomic, then polyatomic. I know that you all have studied this one, but I am just having a recap. Okay? Molecules are made out of atoms. Combining two or more atoms, molecules are made. And these atoms can be classified into two, that is monoatomic and polyatomic. Okay? I can give you one example. Here it is helium, and here there are so many examples. We can take HCl. So many examples are there. Okay? I think you have studied this one, and I think this is very much clear. Now we move on to the next point, that is characteristics of molecule. Characteristics of molecule. Okay? we have four characteristics for a molecule. Okay, first thing is it is small in size. It is very small in size, that much small that we cannot even imagine. Okay, we will come to it. The next point is there is spaces between the molecules. Okay, between two molecules there is a space. You may be thinking or wondering why I am telling there is spaces between molecules, that we will see. Okay, then they are in constant motion. Okay, that means they are moving, they are in motion. Another point is they attract each other. Okay, these are the characteristics of a molecule. First, they are small, there is spaces between the molecules, they are in constant motion, and they attract each other. Okay, then we will see the first point. They are small. They are small means the size of a molecule is 10 raised to minus 10 meter. Okay, we know that 100 centimeter is equal to 1 meter. Okay, so 10 raised to we know 100 centimeter is equal to 1 meter, 1000 meter is equal to 1 kilometer. Okay, but this is 10 raised to minus 10 meter. So how much long it is? How much size it has? We will just see. We know if we consider this as a hair, a human hair. If you consider this as a human hair, this tip is 10 raised to minus 5 meter. Okay, this tip of the human hair is 10 raised to minus 5 meter, and it is a double times smaller. A molecule is double times smaller than the tip of our hair. So it is not visible through our microscopes even. So it is so small. Okay. The next point is there is spaces between the molecules. Okay. Second point, there is spaces between the molecules. Let's see how there is these spaces. We know that there are three states of matter, that is solid, liquid and gas. If we consider this as a molecule and this as another molecule, this is the space between that of a solid. This is the space between a solid, if you think. When we consider it as a liquid, this space will increase. When we go to gas, the space will still increase. Okay, I think it is clear. The point that we have to understand here is the space between the molecules increases when we come from solid to liquid and to gases. Okay, we need this term in the coming definitions also. So the spacing between molecules is termed as intermolecular space. The spacing between the molecules is termed as intermolecular space. Okay. Now we move on to the third point, that is molecules are in constant motion. Constant motion. these molecules are in constant motion. Now consider like this. This is a solid, okay? In a solid, the molecules are tightly packed, okay? The molecules are tightly packed. We know solid means a hard substance. You consider a bench or something like that. So, in a solid, the molecules are tightly packed, so they cannot move. Okay, solid. In solid, the motion of molecules can only vibrate. Okay, they cannot move, they can vibrate, but it is not visible to us. Okay, they move, they are said to be vibrating inside the molecule. Okay, then in liquids, this is not so tightly packed. Okay, in liquids, these molecules can move inside the container. Okay, if you consider this as a vessel, if you consider a vessel, okay, if you consider this vessel, this is filled with water. These molecules can move inside this vessel. They cannot move outside. Once they move outside, they are no longer liquid. So inside the vessel, the liquids can move. These molecules can move. But when we come in a gas, what happens? They are less in number and they can move easily. In the air, they can move easily, and their motion is comparatively more than liquids and solids. Now we move on to the fourth point. The fourth point is they attract each other. They attract each other. Okay. Here we have to consider this attraction between molecules is called intermolecular forces. This attraction is called intermolecular force. Now here we have to consider that it is not the gravitational force or the electrostatic force. Gravitational force, as you all know, it is the force that Earth is having on a substance. But it is that force is also there. Still another force is there, that is called intermolecular force. What do you mean by electrostatic force? Electrostatic force is the attraction between two oppositely charged particles. Oppositely charged particles, they attract each other. Okay, they attract each other. This is called electrostatic force. That force is also not there. This is a different force, intermolecular force. This is the attraction between two molecules. Okay, now this intermolecular force is divided into two. It is force of cohesion and force of adhesion. ADHESION. Okay. Now, force of cohesion means, if you consider like this, H2, you know it is a gas. In H2, the atoms, the molecules of H2, there are so many molecules you think. There is a attraction between these molecules. These all are H. Okay. These all are H, and this is called that the attraction between the molecules of same species, okay, it is called cohesion. Okay. Now you consider HCl. Okay. In HCl there is hydrogen, there is chlorine, there is another hydrogen, there is chlorine, there is chlorine. Here the attraction between chlorine and hydrogen, okay, the attraction between molecules of different species is called adhesion. Okay, I think I am clear. In intermolecular force there are two types of forces. That is, first one is different substance of the same substance, it is called cohesion, and of different substance, different species, it is called adhesion. In this context we have to discuss this viscosity, then surface tension, and all are discussed in the basis of this particular force of attraction between molecules that we will see later. Now we go to another point, that is states of matter. You all know that what are the states of matter. States of matter. So can anybody of you say me what are the states of matter? At least how many states of matter are there? Okay, 3 states of matter. That's right answer. Can you continue to say what are they? Okay, solid, liquid and gas. Okay, solid, liquid and gas. Okay, fine. But this is what you learn in your textbook, but there are actually 3 more that you will study in a higher grade. But basically we will tell that 3 states of matter are there. But you have to keep in mind, then when you go up in your grades, you will learn that there are some more states of matter. Okay, but for the time being you learn like this, you write in your exams like this only, 3 states of matter: solid, liquid and gas. And I think only 6 are there in the 7. Okay. Now we know that states of matter, 3 states of matter. And can you give me an example of a substance that exists in 3 states of matter? Am I clear? I think our audio is not so good. Please, can you just type in the chat box? My question is, can you give an example of a substance which exists in the 3 states of matter? Water. Okay, good. I know that the first chapter you have already learned in your 6th and 7th, but we are just going through a recap. Okay. Now we will see the properties of these 3: solid, liquid and gas. Okay, this is the basic this is the basis of here. First, as we know, solid is rigid. Solid is rigid. You have to study compare. I know that you have already studied, but you have to, when you study, you have to compare this and study. Okay, first, solid is rigid, liquid is not rigid, then gas is also not rigid. Okay, another thing is solid have a definite volume. Okay, solid have a definite volume. We know liquid also have a definite volume. but gases do not have a definite volume. Okay. About shape, we know solids have a definite shape. Liquids do not have a shape, but they take the shape of the vessel or the container in which they are kept, and gases also do not have a definite shape. Okay. This is the basic things that you have to understand. I know you all have studied. Solid is rigid, definite volume, definite shape. Liquid is not rigid, but it has a definite volume. Okay. This is important. Liquid is having a definite volume. Okay. Now we consider another point. This may be new to you. What determines a substance to be a solid, liquid and gas? What are the properties that determines a substance to be a solid, liquid or gas? There are 3 points. First, we have already studied, that is intermolecular space. That means the space between the molecules of a substance. Okay, how it is? Excuse me. Excuse me. Okay. Now what we are telling is there are 3 properties which determine a substance to be whether it is a solid, liquid or gas. Okay. First is intermolecular space. Second is the force of attraction between them. Force of attraction between them. And third is kinetic motion. Kinetic motion or kinetic energy. Okay. What do you mean by kinetic energy? Okay, we will come to it. These are the 3 points which make, when we get a substance, we have to consider these things and we have to analyze whether it is a solid, liquid or gas. Okay, this intermolecular space, force of attraction, kinetic energy. Okay, we will see the first one. More than first one, we will just compare it and see. For a solid, I think all of you know what is kinetic energy. Do you know the difference between kinetic energy and potential energy? What is kinetic energy? Can anybody of you tell me? Okay, let's see. We will say like this. I think this board will help you. First, we will be dealing with intermolecular. Can anybody of you tell me or write in the chat box what is kinetic energy? Okay. Intermolecular space, then kinetic energy, then next one is intermolecular force, intermolecular space. Okay. Have you got? My question is, what is kinetic energy? What is kinetic energy? Can you just type it, please? Here audio is not so good. Is there anybody? Nobody. Okay. Yeah, okay. Kinetic energy is the energy due to the motion of a substance. If a substance moves and there comes an energy, the energy formed due to the motion of a substance. It may not be the motion of a car or a plane, but also it is a motion of a molecule. It may not be kilometers, but it may be 10 raised to minus 9 meters. But there is forming an energy. The energy that is resulting from the motion of a substance is called kinetic energy. Now we will see what? In solids, intermolecular space is very, very less. That means in solids, this is a solid. If you consider this as a solid, the spacing here, if you consider this as a solid molecule, the spacing between them is very, very less compared to liquid and gas. Okay? In liquids, it is moderate compared to gas and solid, and for gas it is very high. They are very high, very away compared to solid. Okay? Now about kinetic energy. Kinetic energy of solid is also less. Why? Do you have an answer? Because the solid molecules cannot move. They can only just vibrate. Their motion is very limited or restricted. And in liquids also they are having a motion higher compared to solid but lesser compared to gas. In gases it is high. Okay? About intermolecular force. Intermolecular force in solids is high. Here it is less. Here it is very less. Very low. Okay? Why intermolecular force is high here? Because these molecules are tightly packed. As they move away, in liquids, this intermolecular force lessens, and in gases they move too much away, so it is very, very low. Okay? I think I have explained sufficiently and more regarding the states of matter. So we have gone very slowly today through the topics, as this is first class. In the coming 2 or 3 classes we will wind up this chapter for matter, and we hope that we can complete this class in at least 2 or 3 periods. Okay? I think I want all of you just type. If you have any doubt, please type now, then we can proceed. Yeah. Okay, tomorrow we will see the molecular model, the next day we will see the molecular model of solids, liquids and gases. Okay, thank you for your listening. Thank you. So let's wind up. Thank you.